Now let me actually talk a little bit about warping. And we're going to get into a lot more detail about this in the next lesson. So here basically I'm just showing you two images, right? So I have a point here and I want to generate a larger point which has been rotated in a newer image space where the domain is x prime, y prime. So this is my coordinate axis, and of course I have my transformation. So I take this pixel and I warp it to this location here. So in essence, what we're doing is sending each pixel from fxy to its corresponding location with a transformation tx in the second image. What happens if the new pixel lands between two pixels? Remember, this could be much bigger in this open space that we're coming up with. In essence, we're taking a bigger image and filling in information from there. In the forward mapping, what's really done is that we would distribute the color among the neighborhood pixels. So this is the pixel I have there. When it shows up there, I would kind of distribute the color in the ones around it to generate a new pixel. And that's what I would actually do. This is the forward warping process. Another well-known process is when we actually go inverse, backward warping. Again, I take a pixel from here and I want to go and figure out the inverse transformation to find where it would actually land up and what would I do with it. So again, in this, what I would do is take each pixel from the warped image and find its corresponding location and move it to the new image as long as I know the inverse. Again, in this case, what happens if it shows up in between pixels? So in this case, what we would do is basically we will interpolate the color values. Those where we were distributing, here we would interpolate the color values and fill it in here from the neighbors. Again, how do we do this interpolation? Remember how we did things like filtering images and stuff like that. We could use those types of methods to help us do this. Just to do a quick comparison, forward versus inverse warping. Which one do you think is better? Well, usually inverse mapping is a better method because it eliminates holes. We're always going from something we know how to get to much more of an original image. And of course, that allows us to fill in all the color information. If we sometimes go from one to the other, we might run into places where we'll have to do some sort of hole filling. I'll talk a little bit about that when we talk about morphing. But the important part is to do inverse warping, we need an invertible warp function. Now I want you all to think about how we would actually create an invertible warp function based on what we've talked about before, and see that in some instances, especially for rigid warps and stuff like that, it's an easily computable inverse function, especially when you have rotations and translations and even scales. It does get harder when you do a bunch of other things, and not all the time, especially when you do have not a global warp. It gets harder and harder to compute those.